Welcome back to the subject Object-Oriented Analysis and Design. Today's topics are mapping design to the code, creating methods from iteration diagram, collections of classes and elements, order of implementation, and design to the code and code to the design. Coming to the first topic, mapping design to the code. So before going to this topic, we need to understand the stages of software development life cycle model. So as we know that software development life cycle models consisting of the stages, the first stage is analysis, the second stage is design, the third stage is developing the code, the fourth stage is testing, and the fifth stage is deployment. That is the end result. These are the major stages in developing the software development life cycle model. Under this, if we observe between the design and code, once the design are done with the help of unified modeling language, as we know under this model we are having the structural diagrams and behavior diagrams. Depend upon the problem statement, we are going to develop the designs. Once the design is completed, the developer needs to map this design to the code. So today's topic we are going to understand how we are going to map the design to the code. Coming to this is an example creating the class definition from designing code to the designs. So how we are going to convert a design into the code. Here we are having a class diagram example for sales and products. Like the products, how we are going to choose. We will have a multiple products. How a salesperson is interacting with the class called product. So as we know the elements of a class diagram and the relationship between the class diagram. In this diagram, if you are going to develop the code, the exact whatever the class is there, to that class we are going to define the name of the class, and then whatever the elements, that is the objects we are having, based on these objects the elements is going to be selected. As we can see that this is the name of the class. The first one represents the name of the class, and the second one represents the attributes or objects, and the third part represents the method or functions. The same a class diagram is going to develop into the code. So if you see here, observe whatever the name of the class, we are going to take it as a name of the class. As we mentioned, for each and every class we need to represent the accessifier, whether the class is a public, private, or what kind of access we are going to define. So at the same time we are going to define the attributes or the elements. So here the name of the attribute colon data type. So that same thing we are going to define here. This is the what kind of accessibility, public, private, or protect. Then we are going to take the data type, and then what kind of name of that element. The next one we are going to take the function or the method. Now depend upon it, whatever the variables you want to declare, you are going to define that, and then you are going to write the object or the method. Based on this you are going to close the class. In the same way, for each and every class we need to define what kind of relation it is having, how we are going to access from one class to the another class. What is that relation between one class to the another class. So this is exactly if you are going to map a model with your code. Let's understand one more example. If you see an interaction diagram, so this diagram is a register. The person is going to register through the online, and the person will purchase some products there. For this example, this is an example for a diagram called interaction model. In this interaction diagram, as we can see, all these are the objects, and the object is having a lifeline, like how much of time it is taking to access a website. Then the user is entered into the website, then selecting the product from the catalog. After collecting the product, they are going to map with the sales. Salesperson is going to give the list of all the items. Based on the list of the items, they are going to keep an order for that particular product. So as we know that this is one of the communication diagram, how exactly it is working, and we can observe that the message which is passed from one object to the another object. So even for these kind of whatever the diagrams we are having, we can map with the code. So as we know that structural and behavioral, with the help of all the structural diagrams, we can map with a specific object oriented programming language. When we talk about the behavioral diagram, the behavioral diagrams are used to just for understanding the working of internal behavior of the problem statement or on a product. So this is exactly how an object or a method is going to be represented. So the previous example, method of the register. So how you are going to write that? Whatever the object is that you are going to define in the code. Coming to the next one, collections. So what we are going to collect, how we are going to collect? As we know that we'll have n number of classes, n number of elements. Out of that, we need to collect exactly which is used to perform, develop the code. So you are going to check that, because we'll have an element that is a one-to-one cardinalities. So one class will have a many class interaction. One class will have a single class interaction, that is one-to-one relation, one-to-many, many-to-one, many-to-many. So these kind of cardinalities or an relationship will be there between the classes and the objects. Depend upon that, we need to collect example elements. For example, if we take the sales items, you'll have an n number of users. That users will initially select some items. Based on that items, again they go for selecting the sub items. Depend upon that, n number of user is going to refer that particular class. Based on that, we need to choose exactly which items that the user has selected in a specific time. Because if you talk about an interaction diagram, we are going to identify the time which is interacted with that particular object. So based on that, we need to prefer exactly whatever the class that are needed. So in the object-oriented programming language, these relationships are usually implemented with the introduction of collecting the objects such as list or map, all those simple elements which are present in your models. So choosing of collection classes is influenced by the requirements. So what kind of requirements are there? Key based lookup required by the use of a map. So to map that, it is related to the exactly whatever the requirement, based on the requirement. So based on the growing order list required, it is going to be checked further, and then we have to select that elements. So if we see one more, the same collections that, so whatever the classes we are having, which is a parent class or which is a child class, what is their relation? Based on the relation, you are going to collect exactly the relevant classes which are to that particular parent class. So what exactly these collections means? If we see here, order of implementation. Now whatever the types of classes we are having, we know that the functionalities of this object-oriented methodology, having that inheritance, polymorphism, and then encapsulation, for each and every technique, the order of arranging the classes is different, and that are depend upon the relationship among one class to the another class. So based on that, we need to define the order of the implementation. So each and every class, we have to check the possible first class to implement, or either the payment or the product description. So when we see a class diagram, let us see the example. So if you see, this is an implementation of a product or a store keeping. So in that, we'll have the first one is the payment. The second order is given for the product description. The third is given for the product catalog. The fourth one is given for the sales line items. The fifth one is given for the sales. Sixth is given for the register. Seventh is given for the stores. So whenever there is an more number of classes are there, first we have to give the order for each and every class. Based on that, we need to develop the code. So whenever we are going to map a design with the code, first we need to check the order of the classes. depend upon the order only we have to map with the code, or the next step of developing the code should be performed. So if you see one more example, how to design making a new class. Now if you want to extend the design, so already you have done the code. Now from that code, if you want to extend that product, or if to extend that whatever the problem statement, now again you have to go back with whatever the class which is whichever the model which is related to that extension. From there again you have to extend that particular module, and again we have to develop the code. We need to map again the design to the code. So this process is continued until the stakeholder or the user is going to be satisfied. So this is all about how we are going to map a code with the a design with the code. So if we come back with this, here the mapping design to the code can be done for especially for the structural diagrams. So as we know that there are two types of models are there, structural and behavioral diagrams. Behavioral diagrams are especially used to communicate within the system or among the stakeholder and the developer. And when you talk about the structural diagrams, with the help of this structural diagram, we can convert the design into the code, and at the same time creating the methods for an interactions. So here we need to follow a procedure whenever you are going to convert the model into the code. Initially we need to identify which model we are going to convert into the code, and in that model what are the major elements are there, and among that elements what is the order of that elements. Initially we need to collect all the important elements or the important objects within that model, then we have to make an order for that. After making an order, the next step is to convert into the exact relevant code. And at the same time that code, if we want to extend further any module, we need to convert again that going back to the same model, extend that model, and then we have to create the code. Simple example, if we take the databases, in the data ER diagram, whenever you are going to draw the ER diagram, based on the ER diagram, it is very simple and easy to draw a table. Like whatever the name of the table, elements of the table, how to convert that diagram into the table. In the same way here also, all the UML models can be easily converted from design to the code. Hope you understood the concept. Thank you.